Assalamu alaikum, students. Today I came with a new video which is related to differentiation, sketches, and trigonometric equations. As you all know, these are three topics which are tested in from 2020 onwards when the syllabus is changed. That's why I have compiled them into one worksheet. All the questions came on differentiation and trigonometric equations. I put them in this sheet. So after doing all these questions, you can see how the examiner has tested on this new skill added in the syllabus. So the first topic is differentiation. Let's see these questions how they can be solved. The basic skills of differentiations has been already explained it to you, but now we will also touch with the application aspect of this topic. So in the very first question, he said that find the x coordinates of the point on the graph. The graph is given to us where the gradient is zero. As you all remember, that the gradient of a graph is dy by dx. So when we take the dy by dx or the derived function, so dy by dx, which is representing the gradient of the graph. How do we do the gradient? The first term, if you see x power 5, so write 5x power 4 because the power goes back and from the power you subtracted 1 minus 5 is already there. So 4 goes back, 4 times 5 is 20. And from power 4, we take off 1 and it will be left 3. Now we need to put it equals to 0. Yeah, why? Because the guy said that the gradient is equals to 0. And we found the derived function dy by dx. Whenever you want to find a gradient, it represents dy by dx. Now this is a simple equation and we want to solve it. When you solve the equation, first you do factorization. Do we have something common? The answer is yes. We have 5x power 3 because x power 3 is the smallest power. So x minus 4 is equal to 0. So either 5x cube is equal to 0, we use the zero product property, or x minus 4 equals to 0. 5 goes to the other side, so it becomes x cube is equal to 0 over 5, which is 0, and send the cube to the other side. So when you send the cube to the other side, becomes cube root of 0. The cube root of 0 is 0, so answer is 0. And from here, we send minus 4 on the other side, becomes x is equals to 4. So he wanted us to find the x coordinate, and we found it. They are 0 and 4. Correct? Regarding the sketch of this graph, I want to just talk about, although it's not being asked by the teacher, by the examiner, but I want to explain it to you how it works. So x power 5 minus x 5x4, we take x power 4 out, and this is x minus 5. If I want to draw the sketch, you can see we have power 4 here, and this is x minus 5. So the critical x intercepts are 0. From here x is equal to 0, and from here x is equals to 5. So when I try to draw it, the graph comes from here, right? It touches, because whenever we have even power, it touches, but it will get more flattened here. It can be square, it can be 4, it can be 6. If it is 6, then we will make it more flatten about the x-axis. Okay, on the origin, it gets more closer to the x-axis. So, but anyways, I try to make it more flatten, and then the graph goes down. So whenever you have any repeated polynomial, so at that time the graph touches, and x is minus 5, so this is one x-intercept. So the sketch is drawn here, but it is not asked by the examiner. There are sketches. I will explain it in detail when it comes to us. So anyways, we found the two points x is equal to 0 and x is equal to 4, where the gradient will be equals to 0. Okay, boys, let's go further. Now, question number 2, he's asking you differentiate. So, differentiate means finding dy by dx. What is the differentiation of a constant? All of you remember when I have taught you, if you see a number without if you see a number without x, it is considered as constant, and the derivative of a constant is 0. Next, 4x. Any number which is written with x, it's the derivative of x is 1, so 4 times 1 is 4. So the differentiation of 4x is plus 4, and the differentiation of x square will be 2x. So we found the gradient or the derived function of this, which is 4 minus 2x. Now he is using the concept turning point. Sometimes examiner uses turning point, or he may use this word which is called stationary point. Both terminologies will explain you one thing. Actually, when I draw the graph, you can see this point and this point. These points where the graph is making a U-turn, you can call them turning point, TP, turning point, or stationary point. So these are the turning point and stationary point. If you draw the tangent on these points, what is the special in these tangents? You will say these tangents are parallel to the x-axis. So any line which is parallel to x-axis, its gradient is 0. Its dy by dx is equal to 0, because gradient is one of the application of differentiation, that it shows the, or it is the definition of the derivative or the drive function, that dy by dx represents gradient of a tangent to the curve. So you put always dy by dx equal to 0. This is like just explanation what happens graphically, but in IGCSE course, when you see turning point or stationary point, what you need to do, guys, you have to get dy by dx, and we already found the dy by dx, which is 4 minus 2x. Put it equals to 0. This is the application or the concept behind turning point and stationary points. You always need to put, if the examiner asks you turning point or stationary point, you found dy by dx and put it equal to 0, and then solve that equation. So we found dy by dx. Now we solve it for x. Send the minus 2x to the other side. So 4 divided by 2 is equal to x. Finally, the x coordinate is found. So we put it here. So this is 2. How to get the y coordinates? We need to substitute the value of x into the original equation, which is 6 plus, not in dy by dx, in the original equation of a curve, to get the corresponding y coordinates. So 4, in the place of x, you substitute 2 minus 2 squared. You may use calculator, and it gives you 10. So y is 10. So at this point, the gradient will be 0. If you want to see the rough sketch, this point is also the vertex of a parabola, because you guys see now 6 plus 4x minus x square. It's a quadratic graph, and the coefficient of x square, the coefficient of x square is negative. The face of the parabola is down. So the face of the parabola is down, and the vertex is, the turning point is 2, 10. um, uh, and the application of dy by d, and the turning point was that if you draw the tangent is parallel to the x-axis. But sketches, I will explain it to you after teaching or after going through with the differentiation. Third question, he is asking you stationary point. So idea is same. Stationary point tells you that you need to find dy by dx and put it equals to 0. That's the background idea. The original equation of a sketch, the curve, it is given to you. It's a cubical graph, and normally the cubical graphs are like this. And he's interested in this point where the tangent is parallel to x-axis and this point. So 2 points. That's why he mentions here. Find the coordinates of the two stationary points. So first, what we will do, we will try to find the dy by dx. So the y will become dy by dx. X cube will become 3x squared. Minus 2x squared will become minus 4x. And you all know the differentiation of 5 is 0 because it's a constant. As it is a stationary point, we need to put the full derivative equals to 0. Now solve it for x. Is there anything common, boys? There is x common. So 3x minus 4 is equal to 0. So either x0 or 3x minus 4 equal to 0. So 3x is equal to 4. X is equals to 4 over 3. We found the x coordinates. Is our job done? No, our job is not done because we need to find the corresponding y coordinate. He didn't mention here find only the x coordinates. We need to find the full point. What is the full point? Yani x coordinate and also the y coordinate. Second point, x coordinate and the y coordinate. You found your x coordinates. One is 0 and the second one is 4 over 3. So with respect to 0, what is the y coordinate? With respect to 4 over 3, what is the y coordinate? To get the y coordinates, you will substitute these values, x coordinates, into the original equation of a curve. So what we need to do now, okay. So first we substitute x is equals to 0 into the original equation. I use the word original because there is also dy by dx here. So some students think like they have to substitute these values of x into the dy by dx here. No, the curve is y equals. So you have to substitute in the y equals the original equation minus 2 0 power squared plus 5. So it gives me y is equals to 5. So our y coordinate is found. So one point is if your x is 0, your y is 5. Now try to find when x is equals to 4 over 3, what is the y coordinate? 4 over 3 cube minus 2, 4 over 3 whole squared plus 5. Now I will use calculator. Bracket open, fraction 4 over 3, bracket close, power 3 minus 2, bracket open, 4 over 3, bracket close, squared plus 5, and we got 103 103 over 27. I hope the calculation was correct. So if your x coordinate is 4 over 3, then your y coordinate is 103 over 27. So imagine how much marks the examiner is putting here, 5 marks. Next question, equation of a tangent. Don't worry, boys. Didn't I tell you that when you have a curve, the tangent to any point on the curve, we can find its equation. How? To find the equation of a line, you need the gradient first. And you know the gradient is dy by dx. So if you know the gradient at any point, suppose he said gradient at x is equal to 4. So the x coordinate is 4, y coordinate is not a big deal. We can substitute into the original equation to get the corresponding y coordinate. So why not? We can find the y coordinate here by substituting x is equal to 4 in the equation of a curve, minus 4. So this is just a starter, that how to start the question. Like the starting of the question needs a full information of the point where I want to draw the tangent. So I know the x coordinate, I want to know the y coordinate as well. Got it? So I'm going to substitute. I got y coordinate 6. Wow. So the y coordinate is 6 plus 16, 16. So when you substitute it here, it gives you y 16. Anyways, so how to get the gradient? For the gradient, we need to find dy by dx and 3x squared for the derivative of x cubed minus 4x squared. It gives you minus 8x and plus 4x is plus 4. Now, don't put dy by dx is equal to 0. Did he ask you to find the stationary point? Did he ask you to the turning point? No, he wants the gradient, which is dy by dx. But gradient is in the form of x. I want a numerical number. Very good. So can you plug, because you want the tangent, the gradient, at which point? At this point. So what is the x coordinate? Can you plug x is equal to 4 here? Because this will give us the numerical value of the gradient. So I go back to my calculator and write 3 bracket open. I'm not finding y value. I'm finding the gradient at x is equal to 4. So substitute 4 into the derived function. So once we substitute, it gave us the gradient 20. So I know the gradient 20. I know the point. Those students who have already done coordinate geometry with me, to find the equation of a line, you need one point on the line, one point, and I want to find the equation of this line. I know one of the point and the gradient, so I use y is equal to mx plus c, and then everything will be done. So that was the rough explanation. Now I want to make the question very neatly solved, and one more time explanation will be conducted. Okay, so let's go on. He said find the equation of a tangent. So the very first thing I do in the exam, I will find dy by dx. So dy by dx is 3x squared minus 8x plus 4, and I this is my m and this is my gradient. So m, I want a numerical value of m. So in the place of x, I substitute 4. So 3, 4 squared minus 8, 4 plus 4. I can solve it and get the answer directly from a calculator. Or if you want to do it manually, so 1648 minus 32 plus 4. So it gives you answer, we found it, 20. 3, 4 squared minus 8 and 4 plus 4. Yes, it's 20. Now I need one point where I want to find the equation of a tangent. So x value is already given to me. X value is already given to me. I need to get the corresponding y value. So x is equals to 4 will be substituted into the original equation. So 4 power 3 minus 4 squared plus 4 times 4. So y is equal to 64 minus 64 plus 16. So it gives me 16, or you guys can get the answer directly from the calculator. So this is y is equals to 16. So the complete point where I want to draw the tangent, 4 is the x coordinate and 16 is the y coordinate. We found it. Okay. we found the point. Now, after finding the point and the tangent, I'll try to find C. So y equals mx plus c. In the place of y and x, we substitute the y coordinate and the x coordinate. So y is 16, m is 20, m is 20, bracket open, and x is 4 plus c. So 16 is equals to 80 plus c. So c is equals to 16 minus 80. So what do we get, guys? Is it 40, 64? 16 minus 80, 64. So we got minus 64. Now we are ready to write the equation of a tangent. How much marks? 7 marks. Lucky boys. So y is equals to mx. So m is 20, x. And what is c? Minus 64. Here you go. We found the equation of a tangent. Now we have a parabola, and you know that parabola has x coordinates. Yani, x coordinate means the x intercept where the graph cuts the x-axis. And how do we solve it? We solve this equation by whatever the solutions comes when I solve this equation. Yani x squared plus 3x minus 4 is equal to 0. When I put it equals to 0, I will get the 2x values. You can use the calculator or the factorization technique to get the 2x values. And those 2x values will be basically the x coordinates of A and B. Let's try to use calculator. Go to the menu, equation mod. I want to know where the curve cuts the x-axis. So cutting the x-axis means graphically, algebraically, it is solving an equation. So polynomial, degree 2, enter 1, enter 3, enter negative 4. Boys, so boys, we have got 1 and minus 4. So x is equals to 1, x is equals to 1 and minus 4. So you say, Mr. This should be minus 4 because it is on the negative x-axis side. So minus 4. What is the y coordinate? If any point is on the x-axis, so the y coordinate is automatically 0. So here it is 1, 0. Wow, we found the A point and the B point. Now there is a third point, and this interesting point is where the parabola cuts the y-axis. So when the curve cuts y-axis, you need to put x is equal to 0, because we know that the coordinates of C, x coordinate of the C will be 0. So what would be the y coordinate? Substitute x is equal to 0 into the original equation of a curve. So 0 squared plus 3 times 0 minus 4. So it gives you negative 4. So we found the y coordinate or the y intercept of a curve when the curve cuts the y-axis at C. So all these 3 points are found, and I was expecting he will ask us what is A coordinates of A, B, and C. So copy them. So this is minus 4, 0, and this is 1, 0, and then this is 0, minus 4. Okay, since it has 4 marks, so if you want to keep your working here, that's all fine. Now the next part is differentiate. The differentiation of x squared is 2x. The differentiation of 3x is 3, and then the differentiation of minus 4, it's a constant, that is 0, no need to write it. Equation of a tangent. So equation of a tangent needs gradient. You found it already, which is gradient represent by m. So in the place of x, you need to substitute the x coordinate, get your answer. So your m is 7. Now you have the complete point, you have the gradient, it will help you to find C. So 6 is equals to gradient 7, x coordinates 2 plus C. This is y is equal to mx plus c. I'm substituting it here. So y equals mx plus c. So 14 plus c, and then 6 minus 14 is equal to c. So minus 8 is equal to c. I'm ready to write the equation of a tangent, which is y equals m was 7x and c is minus 8. Equation of a tangent, again, try to find the derivative first because I need gradient. Gradient normally it is represented as m, and in differentiation dy by dx. The derivative of a constant 18 is 0. No need to write it. Minus 3x if you want it. Let me write it here. So the differentiation of 18 is 0. Minus 3x, it is minus 3 because differentiation of x is 1. Then finally, the differentiation of minus x squared, it is minus 2x. And he wants to find the gradient at 4. So here you substitute 4. So minus 3 minus 2 and 4, it gives you minus 3 minus 8, so minus 11. So my m is minus 11. Am I having the full point? No, he gave us just x is equal to 4. So can you plug x is equal to 4 to get the y coordinate? So if x is equals to 4, we can find the y coordinate be 18 minus 3. In the place of x, I substitute 4 minus 4 squared. Now go to the computing mod. 18 minus 3, 4 minus 4 squared, it gives us minus 10. So minus 10. So the complete point is x is the 4 is the x coordinate and the y coordinate is minus 10. Now, after knowing the point and the gradient, I'm ready to find the equation of a tangent line. Equation of a tangent line is y is equals to mx plus c. In the place of y and x, we substitute the points. Minus 10, m is minus 11, x is 4, plus c. So minus 10 minus 44 plus c. 44 goes to the left hand side to c. So 34 is equal to c. Now we found the c. Equation of a tangent would be y equals m minus 11x plus c, which is 34. Right, boys? Now we go to the question number 7. Stationary points. Remember, stationary points means we need to put dy by dx equals to 0 to get the x values. So let's start. This is the original equation of a curve, and we will try to find dy by dx. So 3x squared minus 3, and the differentiation of 4 is 0. As per rule, to find the stationary point or a turning point, we will put dy by dx equal to 0. Solve this simple equation. Boys, minus 3 goes to the right. So 3x squared is equal to 3. Then 3 goes to the other side. You write it in the denominator. So x squared is equal to 1. Now send the square to the other side. So x square, yani plus minus square root of 1. We always take when square root, we have to write the plus minus sign at the back. The square root of 1 is 1, so plus minus 1. So we got two x values. X is equals to 1 and x is equals to minus 1. So you write here 1, minus 1, and 1. To get the corresponding y coordinates, we substitute these values in the equation of a curve one by one. So if your x is minus 1, and I'm putting x is equal to minus 1, y equals minus 1 plus 4 plus 4, so y is equals to 7. So it gives us minus 1 and 7. This is the first point where we want to draw to get the stationary points. What is the second x coordinate? That is 1. Substitute into the equation of a curve 1 power 3 minus 3, 1 plus 4. So y is equals to 1 minus 3 plus 4. Y is equals to minus 2 plus 4. Y is equals to 2. So x is equal to 1 gave us 2. So point is 1 comma 2. So we need to write these points here, 7 and 2. Ha, a new point. In application, sometimes the examiner asks you, because the sketch is not in front of us, which point is maximum and which point is minimum. In this sketch which I have drawn, you can easily say that, Mr. This is the maximum point and this is the minimum point. Clear? But algebraically, when we solve the differentiation, how can we say that which point? Yani, I really don't know that this point is maximum or minimum and this point is maximum or minimum. How do I check that? Very easy, very simple. You remember that you already found the derivative. You say, yes, we already found the derivative. Can you please copy your derivative here? Your derivative is 3x squared minus 3. Can you please take the derivative one more time? Okay, differentiate again. It is called second derivative. Some people write d square y over dx square, but the symbol is not very important. If you write the second derivative, just take the second derivative like this, 3x squared minus 3. What is the second derivative of this? It is 6x and minus 3. So this is your second derivative. Once you get the second derivative, you need to plug. What are the x coordinates you have? The x coordinate is minus 1 and also your x coordinate is 1. Can you plug it one by one? When you plug x is equal to minus 1 into the second derivative, this is the second derivative, not the first derivative. Once you plug, you get 6 minus 1 is equal to 6. You get 6, a positive number. So if you get a positive number, you always say in opposite sense. If it is a positive number, if your second derivative is a positive number, then your point is minimum. Oppositely, you will say, then your point is minimum. So I say that my minus 1, 7 is a minimum point. Why? Because the second derivative is positive. If the second derivative is positive, we say in opposite sense, it's a minimum point. And the same thing when you substituted x is equal to 1 into the second derivative, what I got 6. Previously we got, guys, it was written 6. Why? Let me check it again. Sorry. Look, 6 times minus 1 is negative 6. So negative 6, it's a negative number. It's a negative number. So negative number tells you this is a maximum point. So this point is a maximum point. And when you substituted x is equals to 1, gives you 6, a positive number. So the opposite of positive, that this point should be a minimum point. So let me write here 1, 2, minus 1, 7. So 1, 2 is a minimum point. I hope I didn't miss anything, because minus 1, 7, when I substituted, I got a negative answer. Is this a maximum point? The examiner was asking the nature of the stationary point. So this stationary point, minus 1, 7, is a maximum point, and 1, 2, because it gives the second derivative positive, so it's a minimum point. So we found both points. In the final exam, how do you solve it? Let me erase everything and do the work neatly. You just find second derivative, or you can write d squared y over dx squared. What is the second derivative? It's 6x. Now when x is equals to negative 1, your second derivative is negative 6. So this shows that since it is a negative, your point minus 1, 7 is a maximum point, and x is equal to 1. When you substitute it into the second derivative, it's a positive. So I say 1, 2 is a minimum point. I hope it clears to you guys. Now we go to the question number 8. He said find the value of y. So can I plug x is equal to minus 1? Use calculator. Bracket open, close, power 4, minus 4, bracket open, close, power 3. So in the brackets, I'm going to write minus 1. This gives us 5. So we show it to the examiner. We are substituting, and we got the answer 5. Now stationary points, we have to get the derivative first. Dy by dx, which is 4x power 3 minus 4 times 3 is 12x squared. For stationary points or turning points, we have put dy by dx equals to 0. So I'm going to put it equals to 0. Is there anything common in them? Answer is 4x squared is common. X minus 3 will be left inside the bracket. So this will give us x is equals to 0, and this gives us x is equals to 3. So 0 and 3. The corresponding y coordinates, we need to plug these values. X is equal to 0 when we substitute it into the original equation. 0 power 4 minus 4, 0, 3, it is 0. And when x is equals to 3, we substitute it into the equation of a curve. We may use calculator to avoid any calculation error. So bracket open, close, power 4 minus 4, bracket open, close, power 3. So in the brackets, you write 3, and we got minus 27. Minus 27. Next question. He said this was differentiated. We got 11x10. It is obvious that P was 11. Why? Because when you differentiate it, 11 goes back, and we write here 10. Clear? So P has to be 11. Number one. Next thing, Q. What should be the Q? You see that the Q goes back and multiplies with 2. So 2Q has to be equals to 10, because 10 is written by him. Q 10 over 2, it gives you 5. If you want to check 2x power 5, what comes to you when you differentiate? 5 comes and multiply with 2, it becomes 10x power 4. Do we have the same thing here? Yes, we have the same thing. It means the Q has to be 5. Straightforward question. Next. Stationary points. Take the derivative, dy by dx. 3 goes back, multiply with 3. So 3 times 4 is 12x squared, minus the derivative of 3x is 3. The derivative constant is 0. Put it equals to 0. So 12x squared, send minus 3 to the other side. It is 3. X squared is equal to 3 over 12. X squared is equal to 1 over 4. X is equal to plus minus square root of 1 over 4. And when you use calculator, you get 1 over 2. So here I'm writing minus 1 over 2, and there 1 over 2. I want to get the y coordinates. So for this, I will substitute minus 1 over 2 into the equation of a curve. So 4 minus 0.5 whole power 3 minus 3 minus 0.5 plus 3. So 4 bracket open minus 0.5 raised to the power 3 minus 3 bracket open minus 0.5 and plus 3. It gave us 4. So this is 4. Now if I write half in the equation of a curve, so remove the negative signs. I got 2. Hence we found the 2 stationary points. As you remember, in this question again, he wants to know the nature of these 2 points. Are these points maximum or minimum? For this, we did it in the last question. What was the method? To find the nature of the stationary point, whether it is a maximum or minimum, we take the second derivative. So what was our first derivative? Dy by dx was 12x squared minus 3. We take the second derivative, we represent it like d squared y over dx squared, or in the exam you can write second derivative. So second derivative of 12x4 is 24x, and the derivative of minus 3 is 0. So 24x. Now 24 of x, we will substitute the x coordinates one by one into it. So if x is equals to minus 1 over 2, what is the second derivative? Negative 12. Since it is a negative, so I can say negative half 4 is a maximum point. Always use the opposite meaning. If it is negative, you say maximum point. And now substitute x is equals to half into the second derivative. You get 12, which is a positive number, which is a positive answer. So what shall I say? That half and 2, this point is a minimum point. This point is a minimum point. Question number 10. A curve is given. We want to find dy by dx. So 3 times 2 is 6, x squared minus 8x, and the differentiation of 6 is 0. Gradient, yani dy by dx, which we found it already. This is our dy by dx, which is called gradient. 6x squared minus 8x, we already found it. In the place of x, you substitute 4. Now use calculator. 6 bracket open 4 squared minus 8 times 4 is 64. So the gradient is 64. By the way, boys, I want to give you one more skill, which is in a calculator to find the gradient of any curve at a particular point. If the x coordinate will be provided to you, you can use the calculator to get the answer directly or to verify your answer. You can see now in a calculator, here the keys which are given here in black. You can find somewhere dy by dx is written. Oh yes, here is d over dx is written. So I need, in order to use this function or feature, I have to press shift and this one. Now here d over dx we want to find, so copy the equation of a curve: 2x power 3 minus 4x square plus 6. So I want to find the gradient at which point? Bring your cursor here. So x is equal to 4. Look, I found 64, so already it is here. So in the calculator you can find gradient directly by using calculator. But if you get the answer directly from a calculator, examiner will not give you the marks for this. You have to show your working. Only calculator can be used to verify your answers. So stationary points. So to find the stationary points, you remember we need to find dy by dx, which is already found. That was 6x squared minus 8x. Put it equal to 0. Is there anything common in 6x squared minus 8x? You will definitely say that. So 2x is common, so this is 3x minus 4 is equal to 0. So either 2x is equal to 0 or 3x minus 4 is equal to 0. So this gives you x is equal to 0, and this gives you x is equal to 4 over 3. Now after finding the x coordinates, we need to find the corresponding y coordinates. So what's the original equation? The original equation is y equals to x cubed minus 4x squared plus 6. So x is equal to 0. I substitute now. It gives me 6. So 6. Now use x is equals to 4 over 3. For this, I need to use calculator. I hope everything was right. 98 over 27, we got it. Yeah, 98 over 27. Next, question number 11, turning points. So turning point means we need to take the derivative. So dy by dx is equals to 3x squared minus 12. Put it equals to 0. So 3x squared is equal to 12. X squared is equal to 12 over 3. x squared is equal to 4, x is equal to plus minus square root of 4, x is equal to plus minus 2. So x is equals to 2 or x is equals to minus 2. Okay, now we need to find the corresponding y coordinates. So if x is equals to minus 2, y is equals to minus 2 cubed minus 12 minus 2 plus 6. So minus 8 plus 24 plus 6. So I'm getting here 22. So this is 22, and now if x is equals to 2, it gives us minus 10. Again, we want to find the nature of these 2 points, whether they are maximum or minimum. So what we need to do, we need to bring the dy by dx down. What was our dy by dx? This was our dy by dx. Bring it down. So this is 3x squared minus 12. Take the second derivative, which is represented as d squared y over dx squared if you want to write it. The most important thing is how do you get the second derivative? This is 6x. Now substitute the x coordinates one by one. So when x is equal to minus 2, your 6 minus 2 is minus 12. Just see the sign of the second derivative answer. It's negative, so it is a maximum point. Minus 2, 22 is a maximum point, and x is equals to 2. When you substitute into the second derivative, it gives you 12, which is a positive number. So I say 2 negative 10 is a minimum point. Next, we have a function in or a curve in factor form. So factor form, when it crosses the x-axis, means we need to put y is equal to 0 or just put all these factors equal to 0. So maybe x is equals to 0. So x minus 1 is equal to 0 will give you x is equal to 1. And when you put it, and it crosses the y-axis means y coordinates are zeros. So it means this thing was 0. So we got x minus 1, x minus 2 equal to 0. So this tells you either x 0, and we are doing it here. So x minus 1 0 or x minus 2 is equal to 0. So that gives us 2. So 0 0, 1 0, and 2 0. So the graph cuts the x-axis. If you try to draw it, I don't know, the examiner will ask you to draw the sketch for this or not, but how this graph will be drawn, the graph comes from here, cuts the x-axis, then cuts the x-axis again at 1, then again it turns back and cuts the x-axis at 1. So it's like this shape, and you see the graph cuts at 0, 1, and 2. Now show that. So he wants us to multiply the three brackets to get this form, because when the three linear brackets x, x minus 1, and x minus 2 multiplied, you will get that answer which is written given by him. So I will just multiply the two brackets first. So x times x is x squared minus 2x minus x and plus 2. Further simplify the bracket, so x squared minus 3x plus 2. Now multiply x inside, so x power 3 minus 3x squared plus 2x. Is it the same thing which we wanted to get? Yes, it's shown. We found it. A turning point. So for the turning point, we need to get the derivative. So dy by dxy is, so x power 3. Oh, x power 3 becomes 3x squared minus 6x plus 2. It's a quadratic equation. You put it equals to 0. Since he wants to get the answer in decimal places, so it is 100% sure, we cannot factorize it. We have to use the quadratic formula. So to use the quadratic formula, my friends, you have to write a is equals to 3, your b is equal to negative 6, and your c is equal to 2. The quadratic formula is x is equals to minus b plus minus b squared minus 4ac over 2a. Now x is equals to minus minus 6 plus minus minus 6 whole squared minus 4, 3, 2 over 2a, 3. Now the job of calculator starts. Go to the equation mod, polynomial, degree 2. Enter 3, enter negative 6, enter 2. So we got the first answer, 3 plus square root of 3. You have to copy 3 plus square root of 3 over 2. And the second answer will be definitely 3 minus square root of 3 over 2. But we need to write them in decimals. What is this? 1.577. 1.577. And the second answer is 0.4223. 0.423. Okay, so these are my x coordinates. Let me copy them. Did he say to write them into the one decimal place? Yes. So I should write here 1.6 and 0.4. To get the y coordinates wise, we need to substitute these x values into the original equation of a curve. Where is the original equation? X cubed. So take it to the side. Go to the computing mod, bracket open close, power 3, and then minus 3 bracket open close power 2 plus 2 bracket open and close, and now in the brackets write here 1.5. Try to write more than one decimal place to get your accurate answer. 1.577, 1.577, and 1.577. So we got minus 0.38. So in the one decimal place, it should be minus zero point 0.4. So minus zero point 0.4. Next, delete 1.577. We will write 0.423, 0.423, and then 0.423. Last one, 0.423. It give us 0.38. So to one decimal place, it should be 0.4. Interesting. Um, so guys, we found the stationary points. Now we have to draw the sketch. Didn't I explain you the sketch before? We saw that this graph f of x was x minus 1 and x minus 2, and it was having three x-intercepts. The graph was cutting at 0, at 1, and at 2. So this is 1 and this is 2. So the graph came from here, cuts from here, and goes down. So this is the sketch. We found one maximum point, this 1.6 minus 0.4. So I can say that this is 1.6 and this is minus 0.4. So this is a minimum point, and the other point is 0.4 and 0.4. So this is 0.4 and also this is 0.4. But in sketch, he doesn't need all these important points. The shape is important, and where the graph cuts the x-axis, that is important for us. Now, question number 13, maybe the last one now. So we want to find a turning point. So dy by dx. So 3x squared plus 16x plus 5, put it equals to 0. is a quadratic equation. Go to the equation mod, polynomials, degree 2, enter 3, enter 16, enter 5. What are the two answers? Minus 1 over 3 and minus 5. Write these values in a factor form. So in a factor form, it should be 3x plus 1. And this one in a factor form will be x plus 5. Otherwise, the examiner will not give you marks if you write the answers directly. Okay. And if you want to write the step in between, how the factorization was done, so you can expand it. So 3x squared plus 15x plus x and plus 5 equals to 0. Okay. If you want to write it, otherwise, no need. Now, this put this thing equal to 0 or this factor equal to 0. So 3x minus 1, x is equal to minus 1. The x coordinate, we found it, x is equal to minus 1. Do we need the y coordinates as well? No worries. So minus 1 over 3, and this is negative 5. To get the y coordinates, y is equals to minus 1 over 3 whole power 3 plus 8 minus 1 over 3 whole squared plus 5. Use calculator. Be careful when you are plugging the values and writing the values into the calculator. Plus 8 minus 1 over 3 power 2 plus 5 is 1 over 3, right? So we get the answer minus 22 over 27. Minus 22 over 27. That's the y value. Same thing for x is equal to minus 5. So we got 50. So this is 22 over 27, and we write here 50. Now, nature of the turning points, copy the dy by dx because we want to take the second derivative. So dy by dx, 3x squared plus 16x plus 5. So take the second derivative. You can also write it as d squared y over dx squared. So 6x plus 16. Substitute the points one by one. If x is minus 1 over 3, 6 minus 1 over 3 plus 16, it will give you 14, which is a positive value. So, minus 1 over 3 minus 22 over 27 is a minimum point. Also substitute x is equals to minus 5. It will give you minus 14, negative answer. So this tells you minus 5 and 50 is a maximum point. So boys, we are done with the differentiation, then sketches will start. I hope all of you understood the concept of differentiation, which is newly introduced after 2020. So there are 14 exams have been already conducted by the 14 exam means 14 past papers available from where I extracted these questions for your preparation on differentiation. Thank you. Assalamu alaikum wa rahmatullahi wa barakatuh.